Here's another example with formal charge. This looks like a strange molecule, doesn't it? Xenon trioxide. You wouldn't normally think that xenon would form compounds. It's a noble gas. But some of those large noble gases like krypton, xenon, they can form some compounds. Now I gotta be honest with you, there's like a billion ways that you could draw this. Well, maybe not a billion, but there's a ton of different structures that could all be acceptable. Now again, how do you start this thing? Because normally if you were to draw like, xenon's Lewis structure, you'd have 8 dots around the outside, and then where are you going to put the oxygens? So this might be a good one again to try something. Give everybody at least an octet. Xenon needs at least an octet, but obviously can take more than an octet because he's in the 5th energy level. But oxygen must have an octet. And then we'll check electron count. We'll see if it's right. While I'm thinking about it, I might add the electrons right away. Xenon carries 8 valence electrons, and then oxygen would have 6 times 3. So that will give me a total of 26. And it's neutral, so I don't have to worry about any kind of charge or anything like that. Okay, so let's just get after it, huh? Let's try drawing something. Man, xenon. Let's try single bonds. Okay, oxygen needs at least an octet. I'll go around and give him some dots. There we go. At least an octet. That's a dot. There's the oxygens. Xenon right now only has 6. So we'll just give them a lone pair. Now you wouldn't have had to draw the oxygens at like 120 degree angles. I just kind of drew them like that because if you really did have 3 atoms bonded around a central atom, that's a typical arrangement where those electron clouds are going to repel, so you may really get like a 120 degree angle. You wouldn't have had to draw them like that because again, we don't really know what this is going to look like until we finish drawing it. Right now I've given 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. 26 electrons. I just had to make sure I put that extra lone pair on the xenon. Alright, well there's one acceptable option. Everybody having just octets. Okay, so now where do we go, huh? You can do whatever your little heart desires. You can go kind of crazy here. Xenon. Since xenon can take an extended octet, you could do like all double bonded oxygens. Let's see what happens here. The oxygen must have an octet, so we'll give him his octet. Right now, xenon's got 2, 4, 6, 8, 10, 12, but I've only used 24 electrons. So the last 2 just get dumped on the xenon again. Cool. It's acceptable because xenon has d orbitals. Now again, you could go kind of ridiculous. And you could do like a single bond, a double bond, and a triple bond. And then give oxygen an octet. He must have an octet. There's this guy. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Can you see how the possibilities are endless? I mean, not completely endless, but you could have all kinds of different combinations of single bonds, double bonds, triple bonds, and it's all possible because that xenon in the center can take an extended octet. So, I don't know, like what if they just said draw 3 acceptable structures? These are acceptable. Oxygen can only have an octet. Xenon can take more. And in each case, I use 26 electrons. So now we would do formal charge to see which of these structures that I drew would maybe be most stable. I don't know if any of these are stable because, again, there are tons of different ways you could draw this thing. So let's see what we got. Again, I'm going to label these oxygens as A, B, and C. A, B, and C. A, B, and C. So let's do the xenon first. The xenon normally has 8 valence electrons. I have given him 1, 2, 3, 4, 5. Ooh. For a formal charge of 3. The lone pair goes solely to that xenon. And then in those single bonds, I split them. 1 electron to the oxygen, 1 electron to the xenon. In this case, all the oxygens are going to be the same. Normally has 6 valence electrons. I've given them 7. For a formal charge of -1. And they would all be the same. 7, -1. Oxygen C. -1. So at first glance, I don't see any zeros. So I kind of liked this structure. You know, it had the single bonds. It was kind of cool. But I don't have low formal charges. I don't have any zeros. I got that 3 in there, which is a little wild. Although it does add up to neutral. Since this is a neutral molecule, if I add the formal charges, I should get 0. Let's try the second one. Xenon. Normally has 8 valence electrons. I've given him 1, 2, 3, 4, 5, 6, 7, 8. Cool. There's a 0. 1, 2, 3, 4, 5, 6, yep, 7, 8. The double bonds get split. That's really 4 electrons, but 2 go to xenon, 2 go to oxygen. And then there's also a lone pair. Each of the oxygen in this case are the same. Oxygen A, B, and C will all normally carry 6 valence electrons. I've assigned 6. Well, what do you know? This one's looking rosy, huh? 6 minus 6 for a 0 and oxygen C. I have a feeling this is going to be a good one. It's obviously neutral and all the formal charges are 0. But for kicks, let's do the last one. Xenon only has 8 valence electrons. I've given 1, 2, 3, 4, 5, 6, 7, 8. Whoa. For a 0. Ooh, that's looking good. Is this one going to be competitive? Again, a single bond counts 1 for xenon, 1 for oxygen. The double, 2 for xenon, 2 for oxygen. The triple, 3 for xenon, 3 for oxygen. So I'm going to do oxygen A. There's 6 unbonded electrons and 1 from the bond. -1. Oxygen B. Normally oxygen has 6 valence electrons. I've given 6. A formal charge of 0. And then oxygen C. Oxygen normally has 6 valence electrons. I've assigned 1, 2, 3, 4, 5 for a formal charge of 1. It does add up to neutral, but it's got some numbers in there that are not zeros. We want as many zeros as possible, meaning that in our structure, we've assigned the amount of valence electrons that the atom would normally take. Just by chance, I think I drew the best structure. Look at that. That second one's the best. Now, again, what if by chance you didn't draw that? What if the question said, draw 2 acceptable Lewis structures, use formal charge to say which is best? Well, in that case, you're probably going to say that Wacko structure is best. It's got the lowest formal charges, it's got 2 zeros, and then it's just got some 1s and a -1. That red structure is better than the first one, which is, I don't know what color that is, like a plum color. A formal charge of 3 is not stable. That xenon would like 8 valence electrons. In my structure, I only gave him 5. Even though he does have an octet, if I look at how those electrons are distributed in the overall structure. So again, you may not have picked the best structure, but you can use formal charge to say which of the structures you did draw is most likely the stable structure, the most stable structure of whichever ones you did draw.